it's continuous between 1 and infinity. The only thing that would make it discontinuous is if even nothing would make it discontinuous, right? Because there's nothing I can plug into here that's going to get a 0 denominator. Okay, so we know it's continuous. We know that hopefully it's positive because that's squared. I'm not going to put any numbers in, so we know that part, and we're going to write that out in a second. But I'm going to try my decreasing, so I'm going to plug some numbers in. So 1 over, let's see, 1 squared is 1 plus 5 is 6. 2 over 2 squared is 4 plus 5 is 9. Let's see, 3 over 3 squared is 9 plus 5 is 14. All right, so that is beyond my brain's ability to figure that out in my head. I'm going to actually find my decimal points. So 1 divided by 6, this is 0.16. 2 divided by 9, oh, that's not good. 3 divided by 14, 2, I'm not batting very well today. Oh, you know what happened? Let's look at beyond there. It's not positive and decreasing until it hits 3. Let's try putting in 4, because right now it's increasing, right? So let's try 4. 4, and then 4 squared is 16. 16 plus 5 is 21. So 4 divided by 21, ooh, there we go, 0.19. Okay. Sometimes we have to go beyond the first 3 to get something that works. So it'll be 5 over 25 plus 5 is 30. 5 divided by 30 is, so here we go. Now we're decreasing. So we're decreasing after 3. After 3. Okay, that's what's going on with that one. Yes, Lorenzo, we could find the derivative of the function as well. Okay, that works too. All right, there's a couple ways to do it. Okay, what we actually have to do is we have to, one way or the other, make sense of this. So either you find your derivative and you prove that it's just negative, okay, or you can do your terms. But notice I had to go a little bit further, right, than I normally do to show decreasing. And I'm going to have to make a statement about it. It doesn't happen until 3. Okay, but I do need to write that down. Okay, so I need to make the statement f of x is positive, continuous, and decreasing, because I have to prove that it's part of the theorem. And decreasing for x greater than or equal to 3. Okay. All right, so then I know I can write the integral from 1 to infinity of n over, I'm going to actually switch it to x's instead of n's. That's what we normally do. So x over x squared plus 5 dx. And we're going to have to use improper integrals. N greater than, oh yes, it would be n, thank you, not x. Thanks, Gabby. Okay, so we are going to, so I'm going to go the limit. So apply the integral test. Limit as b approaches infinity from 1 to b of x over x squared plus 5 dx. Okay. All right. Okay, here, I haven't asked hardly any questions yet today, right? I'm sorry. What am I going to have to do to integrate that? What am I going to need? Everybody tell me in the chat, what are we going to need? Oh, okay, I'm going to keep waiting. I'm going to wait and make sure everybody's paying attention. So I only got 2 answers so far. Gabby, you can take the derivative, so there's 2 ways you can prove it. They're not actually going to look for the proof. They're going to look for that you wrote that it was positive, continuous, and decreasing. And in this case, you would have had to say n greater than or equal to 3 or n strictly greater than 2. Okay. So you need those things, and you need to somehow rationalize that it's decreasing. So either list the terms or take the derivative and get it greater than, or get it less than or equal to. The square root of 5 They didn't show me that. But as long as is the square root of 5 less than or greater than or would be greater than 2? So I think that they put greater than 2. It is, isn't it? Yes, you're just going to show that it's decreasing over the interval, and it's from 3 to infinity, not 1 to infinity. Okay. All right. Let's keep going. We are going to have to do a u sub. Okay. So u is going to be equal to x squared plus 5, which means that u prime is going to be, or is du, sorry, I'm thinking chain rule, or is equal to 2x dx. So I know that I need to add in a 2 in the top and the bottom, right? So a 2 in the top and a 2 in the bottom outside. All right. So when and I'm going to rewrite this a little bit. So I've got the limit as b approaches infinity of 1/2 from, it's going to be the u is going to go in for the 2x plus 5. The 2x dx is going to become du. All right. Everybody should be able to answer this and answer it quickly. What is the integral of 1 over u? All right, you guys are right. We have the natural log, and it's going to have a 1/2 out in front. Natural log absolute value, and instead of writing u, I'm going to write in the x squared plus 5. Okay. So when I put infinity in here, okay, so when I plug that infinity in, natural log infinity squared plus 5, it equals infinity. So when it equals infinity, yes, I have to put the bounds. Did I mess up? I didn't put the bounds. It would be 1 to be, oh, you know what I did? I didn't show all of my steps, did I? Thank you. Apparently I'm not awake this morning, or I've been up too long, one of the two. So it's the limit as b approaches infinity of 1/2, or did I just miss the bounds? Natural log of absolute value of x squared plus 5 from 1 to b. And then I do the limit as b approaches infinity, 1/2 natural log absolute value of b squared plus 5. This is the proper way to do the work. I missed this line. Natural log of 1 squared plus 5. And then we plug the infinity in. I was just too excited about getting infinity. Minus 1/2 natural log of whatever this mess is back here. This thing is going to become infinity, so the whole thing equals infinity. Does it converge or diverge? So on an improper integral, if it equals infinity, or on the whatever this is the, yeah, it's an improper integral. If it equals infinity, and we learned this a long time ago, that it diverges, right? If it equals anything else, it converges. So we would say therefore diverges by integral test. Okay. I'm going to give you guys a minute to make sure you've written everything you need to write. I think we chatted too much at the beginning. I haven't gotten enough done yet today, have I? Okay. Let's take a look at this one right here. That one should go fast, right? Because it's a p-series. That's our favorite one, isn't it? Okay, if that's a p-series, before I do any work on it, I'm sorry your Wi-Fi cut out, Samuel. That's been happening to me like once a day right now. And it's funny because it cuts out on one computer, my personal computer, and it doesn't on my work one. All right. It just takes a few minutes to get back. I usually have to unconnect the internet and reconnect it, and then it comes back. All right. What is the P, everybody? Tell me what the P is. I'm not going to do anything with it until you tell me what you think the P is supposed to be. All right, everybody's saying 4/3. So I could rewrite this series as 5 over n to the 3/3 n to the 1/3, right? That's what you're telling me. And then I get, when I multiply, I add the exponents, so n to the 4/3 power. So p is equal to 4/3, and that is greater than 1. Go back to your orange sheet. Does do we converge or diverge? Okay, so remember when we take this test, the answer that you enter is probably going to be converges or diverges, but I also want you to tell me, I might ask you on this one, like what your p-value is, okay? But you need to make sure you're showing me work on the paper. If I get a test back that just says converges, diverges, and I'm not giving you credit for that, okay? Even if it's right, all right? You can't just guess on me, all right? I want to see that you're actually demonstrating the work, okay? So converges by p series. Okay. In the interest of time, since we've already done, I will come back and I will, if I don't get to, I'm going to skip over 13 and we can come back to it. Let's do, we haven't done a direct comparison together yet. So let's do 14. And I think 15, actually, the limit comparison might work this time. So let's try 14 and 15, see if we can get those ones to work. And then if we've got time, I'll come back to 13, okay? And if not, we have a few minutes on Wednesday too, all right? Okay, so direct comparison test. So what do you think on this one? I'm looking at 14. What do you think we should compare to? What do you guys think? Lorenzo was like super ahead of me. Gabby's there. All right, so you guys are just basically dumping the 1, is what you're telling me, okay? And the fancier, better way to write this would be, so I'm going to compare to the sum as n equals 1 to infinity of 3/5 n. Why did we choose that? Because what are we going to use to compare? What test? What test are we going to use to compare? All right, geometric. Spelling doesn't count. All right, so we know this is a geometric series, okay? You all know I can't spell, okay? It's like the best class ever when spelling doesn't count. Thank God for spell check, right? Okay, so our R is equal to 3/5. All right, I'm not going to flip back to the orange sheet this time, okay? Is 3/5 bigger than 1 or smaller than 1? Is it less than 1 or greater than 1? Oh, you all had convergence typed in, and I didn't ask that question, did I? Okay, it's less than 1. I asked if it was bigger or greater than 1, but you all told me that you think this converges. So this converges. Okay, but I can't tell if that piece converges, right? All right. We still need to decide if by direct comparison it converges. So remember, this is BCSD. So I need my comparison series to be bigger, okay? So I just test this by putting in terms. You have to make a statement. Usually we say since, and we write the original series, and we have to put some kind of inequality sign in between that and the whatchamacallit, and the comparison series. So, but I always take some time and I put some numbers into it to see if I actually have the bigger series or the smaller series, okay? So I'm going to put a 1 in. So I get 3 over 5 to the first is 5 plus 1 is 6. So that's equal to 1/2. And then this would just be 3/5, which I believe is bigger than 1/2. Like 2.5 would be 1/2. Let's do another one just to make sure it doesn't do anything goofy, okay? So let's see, 3 squared is 9, 5 squared is 25, plus 1 is 26. And then this would be 9/25. Well, that's kind of easy to tell. 9/25 is going to be bigger than 9/26, right? I could do more, but I'm pretty confident after 2 of them that came out pretty good that this one is bigger, okay? So therefore, this series n equals 1 to 5 of 3 to the n of 5 over 5n plus 1 also converges, okay? All right. Let's see if we can get the limit comparison test to work out today, okay? All right. So, limit comparison, again, or on this one. Hopefully this one works better than the first one. What do you guys, let's see, oh boy. What do you guys think we should compare to? Because that one's weird, right? So Gabby says she did n over n cubed. Okay, and Lorenzo is kind of on the same path, except that he left the 3n in there. I like the 1 over n squared. I'm thinking that might be a good idea, okay? Because again, think about what we're doing. We're talking about something that's going to infinity. So any number that's small, like 3 and 1, those are going to be fairly insignificant, okay? So when I try to make a comparison series, I kind of ignore the numbers, unless I've got some exponential that I've got to deal with, okay? So really what I'm seeing is what Gabby saw, and Lorenzo to the point. I'm seeing the n on the top and then n times n squared on the bottom, which would be n cubed, which is the same as 1 over n squared, okay? So I'm going to use that as a comparison, because what kind of a series is that, everybody? What kind of a series is that? That is a P series. That is correct. Okay, so P series, what's your P equal to? Okay, 2, good. All right, which I know is greater than 1. So does the P series part converge or diverge? I can tell we have some of us have our orange charts in front of us, right? Our orange papers. So converges. Okay, so now let's try the actual limit comparison test and see if we can get it to work out this time. So we've got the limit as n approaches infinity. Remember, we take our original, goes in on the top, n times n squared plus 3, okay? And then we divide by the comparison, or we multiply by the reciprocal. Okay, I am going to distribute the n squared through and the n on the bottom, okay? So I still have the limit as n approaches infinity of n cubed plus n squared over n cubed plus 3n. What's the limit equal to, everybody? All right, it is in fact equal to 1, okay? So if that's equal to 1, then let's see. I'm looking back at my notes here. Which one is this? 15. So it converges, right? If I look at the comparison test. So if it's greater than 0, either both converge or both diverge. So greater than 0, therefore the series n equals 1 to infinity, n plus 1 over n times n squared plus 3 converges by limit comparison test. Okay. All right. Where are we on what we have left? 1, 2, 3, 4. Okay. I am going to stop there. Okay. I will video this one for you. Okay. And I will try to figure out what was going on with the other limit comparison test. I think it might have been an ugly problem. And then I may even, if the mood strikes me, I might video one of these two down here. So then on Friday or on Wednesday, we have to do 18, 19, 20, and 21.